Okay guys, so we're moving on today to the fundamental principle of counting. Now we did a little bit of it yesterday, so this yellow box here I want to take down in your notes. So I'll just go through it. So this is what it means in words. So it says if one trial has n possible outcomes and a second trial has n possible outcomes, then the total number of possible outcomes is m by n. Okay, so just take that definition down into your notebooks. So it's actually quite easy. That just sounds a little bit more complicated there, but once we do an example, you can see. So it says a six-sided die is rolled and a coin is flipped. How many different possible outcomes are there? So we know that when we roll a die, we have 6 outcomes. So it's 1, 2, 3, 4, 5, 6. And then the total number of outcomes for the second trial, which was the coin being flipped, is 2. So you either get a heads or a tails. So then the total possible number of outcomes, you just simply multiply them, which that's what we mean by the m by the n. And here it'd be 6 by 2, which is 12. So remember that the total number of outcomes is that we multiply each time. So I want to take down that example. So another example here then, it says a teacher puts label on desks in an exam hall. Each desk is labelled with a vowel followed by a digit. For example, you could get E7. So how many different ways can the desk be labelled? So again, there's 2 trials here. So we'll see what's the outcome for the first one. So the first one is a vowel. So our vowels are A, E, I, O, and U. So there's 5 outcomes. And our digits are 10. Okay, so we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the number of different ways in which the desk can be labelled is 5 by 10, which is 50 ways. Okay, so the main thing then that you need to know there, that the fundamental principle of counting, basically all we do is we do m by n, okay? And m would be the outcome for the first trial and n would be the outcome for the second trial. So moving on then to the next one, if they said a customer wishes to place an order in a pizzeria and is given the following choice for a meal. So all your starters then, you could have a potato wedge here, just look at here, garlic, chicken, bread and ciabatta. Pizza then, there's all the different types of pizzas you can have. You have 3 options for your drink and you have 2 options for your dessert. So if a customer chooses a starter, a pizza, a drink and a dessert, how many different ways can the 4 course be ordered? So then this is using the fundamental principle of counting. So you have to see the outcome for each one and then we multiply them. So if you look at a starter then, so there's 4 options for the starter. So we have 4, okay, multiplied by, for the pizza then we have 3 options. For the drink we have 3 options and for the dessert we have 2 options. So all the outcomes then we multiply them. So if you did 4 by 3 by 3 by 2, you get 72. So that basically is the fundamental principle of counting. So in the first one, we just had always 2 trials, but here you had 1, 2, 3, you had 1, 2, 3, 4 trials. So you just multiply the outcome of each one. So that's what we mean by the fundamental principle of counting. Okay, so we're just going to go on to probability, and there's certain terms that you need to know that come up all the time in questions. So we need to know these terms. So I wanted to write these down into your copybook. Okay, so the first one then that they have here is they said a trial. So a trial is the act of doing an experiment. So like rolling a standard 6-sided die, an example of a trial. So a trial is the act of doing an experiment in probability. An outcome, so an outcome is one of the possible results of a trial. So like when rolling a 6-sided die, a possible outcome is 4. An event is the occurrence of one or more specific outcomes, like so getting a 1 or a 2, an example of an event when rolling a 6-sided die. And the set or list of all the possible outcomes, so this one comes up the whole time, they'll ask you to write out the sample space, is called the sample space. So it's a set of lists of all the possible outcomes is called the sample space. So example, for a roll of a 6-sided die, the sample space is 1, 2, 3, 4, 5, 6. Okay, so remember the last time we were doing the different ways of doing all the possible outcomes. So you could list them, you could do a 2-way table, or you could do a 3-way diagram, and all of that then would be your sample space. Okay, so then we have to do likelihood of scale. So this is another thing that I wanted to put into your notes and to learn off by heart. So it's the likelihood of scale. So if we use the likelihood scale when we use words to describe the chance of events happening. So we use such words such as impossible, then it's unlikely, then evens, okay? So just look at evens, it is halfway in the scale, okay? So evens means it has a 50-50 chance or equal chance or are used to describe events that have even chances of occurring, okay? So 50-50 or even chance, then you're getting closer to the event happening, so it'll be likely and then it's certain. So the main problem when using a likelihood scale is that one person's understanding of a particular phrase or term, such as likely, might differ from another person's understanding. So we just have an example here then. So mark on a likelihood scale given the chance of each of the following event occurring. Okay, so a fair coin is flipped and lands on a head. Then a letter chosen at random from the English alphabet to be a vowel. And then a standard 6 die would land on an 8th. Okay, so to do this one anyway, so the first thing we do is we just have to draw our scale. So we'll say this is our scale. Okay, so here would be impossible and here would be certain. Okay, so the first one they asked us, a coin is flipped and lands on a head. Now when you flip a coin, you have two options, a tail or a head. So it has a 50-50 or an even chance of landing on a head. So we'll say halfway here. Okay, so we'll say our halfway scale is here, we'll say roughly. So then I would put A here. So it's halfway. So a letter chosen at random. So the next one then was a letter chosen at random from the English alphabet to be a vowel. Okay, so the vowel is A, E, I, O and U. And in the English alphabet there's 26 letters. So that is, we'll say 5 out of 26. Okay, so the chances of you getting that would be unlikely, okay, because there's only 5 vowels. So unlikely then would be B here. And then they said the next one then that they want you to write in is a standard 6-sided die would land on an 8. Well, you know that the outcomes in a die can only be 1, 2, 3, 4, 5 and 6. So you cannot get an 8. So an 8 is impossible. So we mark it in as C would be impossible. Okay, so that's marking in a scale where you're having impossible, unlikely, evens, likely and certain. Okay. Okay guys, so then you have a probability scale where you have to have it in 0 to 1, okay, or percentage 0 to 100%. Instead of using words that we did the last time, you have a scale going from 0 to 1. Okay, so a chance of event occurring can be shown on a probability scale. The scale goes from 0 to 1 or 0% to 100%. Probability is a numerical measure of the chance of an event occurring. Okay, so when you get answers in probability, and if you get an answer greater than 1, then you know you went wrong, because probability is only always between 0 and 1. So the probability of 0% means that event will never happen, so it'll be impossible. So like something that's impossible is like we'll say pigs can fly. Okay, at this exact moment that is impossible. A probability of 1 or 100% means the event will definitely happen, it is certain. Okay, so something that is certain, it will be on your next birthday, you will be 1 year older. So if you just say you're 14 now, on your next birthday, then it's certain it's going to happen that you will be 15. Okay, a probability of a half or 0.5 or 50% means that is an even chance of happening. So an even chance is like when you flip a coin, you have an even chance of getting a heads or a tails. It's 50%. So the closer the probability it is to 0, so the closer it is to 0, it is less likely to happen. And the closer the event is when it passed 0.5 and it's getting closer to 1, it is more likely the event will occur. Okay, so all of this then I want you to put in your notes. So using the example there for this one. So for each event, mark below on the probability scale an estimate of its probability. So that you will draw a red card in a single pack from a standard pack of playing cards. Well, if you just go across here then, so there's 62 playing cards that are red. Okay, so 26 out of 52. So there's 26 black and 26 red. So 26 out of 52 is a half. So that would be 0.5. So a fair-sided die, you will land on 2. So there are 6 outcomes. So 1, 2, 3, 4, 5, 6. Okay. 2 is one of those outcomes. So it would be roughly here. So it's less likely that you'll get a 2 out of 6. So a baby will be born in the world today. Okay. So that is certain that there's a baby born. So we put that as a 1. Okay. So a baby will be born in the world today. We put that. That's a certain. So it would go 1. Out of a bag of red and yellow marbles, a blue marble is drawn. Okay, so there are no blue marbles in the bag, so it's impossible. Because if you look at the bag, it only said red and yellow, so that's impossible. And impossible will go at D. Okay, so I want to take down those notes, and we'll be doing questions on probability scale and the fundamental principle of accounting for homework.